In this lesson, we're going to look at trig identities, which is a little bit different than solving. When we are working with a trig identity, we are trying to prove that a statement is true. So we want to prove, sort of like when you did in grade 9, if you wanted to check your answer, you did a left side, right side check. So that's what we're doing with these identities, is that we want to prove that the left side of the equation is equal to the right side of the equation. So in grade 11, it's more of an introduction. In grade 12, you'll do a lot more complex trig identities, but in grade 11, we just sort of get you familiar with writing a proof and all the identities that we can use. So I did give you a formula sheet. Those are the trig identities that we're using in grade 11. Please stick to those trig identities. In grade 12, we have a lot more. And there are many, many trig identities out there. Trig identities are statements that have already been proven true. So we can use them, just like Pythagorean theorem. We know that a squared plus b squared equals c squared. We know that's true, so we can use it to solve problems. So trig identities are the same. They've been proven to be true, so we get to use them in proofs. But we are limiting to certain ones in grade 11. As I said, in grade 12, you'll get way more. So we want to stick to the ones that we have on the formula sheet. So a couple of strategies. As I said, you want to make sure that the left side is equal to the right side. So you are going to work down either the left or the right. We don't write an equal sign in between because we have not proven that they are true. Right? So if we haven't proven they are equal, we can't say they are equal. So we write left side and right side, or we can write them in a T-chart, which kind of keeps them separate. You can't move terms from the left side to the right side or vice versa. You have to only work down this side separately. And the first strategy we usually do is that we replace all terms with sine or cosine if they are not already in that form. And you'll have it a little clearer when we start to do them. After that, we simplify. So there's lots of things we can do to simplify. We can add like terms, we can factor, we can expand, we can find common denominators, multiply fractions, anything that we can do to simplify. And another thing, you want to keep an eye on both sides as you work. So you don't want to blindly go down one side. You want to keep an eye on what you're trying to prove on the other side. So here's a very simple one to begin with. We want to prove that cosine theta times tan theta is equal to sine theta. So I'm going to do a T-chart. So I'm just going to write a T-chart here. And I'm going to put the left side here and the right side here. So you notice that I'm not writing it equals. I'm just keeping them separate this way. So on the left side, I have cos theta times tan theta. And on the right side, I have sine theta. So on the right side, there's really not much to do. It's just sine theta. I can't really do anything with that. On the left side, I see the term tan. If I look at my formula sheet, I see that tan theta is equal to sine theta over cos theta. So any term that is not in sine or cosine, I would like to replace it with something that is in sine and cosine. So I replace the tan with sine over cosine. And then what can I do to simplify? Well, I can multiply these two together. So cosines over 1. So in the numerator, or I could just reduce, now that I'm looking at it. So I can reduce cosine on the top, cosine on the bottom, and that leaves me with sine theta. So now I see that the left side equals the right side, and we are finished. So once you get the left side equal to the right side, you're done. Okay, let's look at the next one. So again, I'm going to use a T-chart. You can write left side, right side as well if you want. So on the left side, I have sine x over tan x. And on the right side, I have cosine x. So on the left, I see a tan that I could replace. And it doesn't matter if it's x or theta. So tan x is equal to sine x over cosine x. I see that on my formula sheet. What can I do to simplify? Well, I'm dividing, so I could take the numerator and I could multiply by the reciprocal of the denominator. Now, what can I do to simplify? Well, I can reduce. I see that there's a sign in the numerator, a sign in the denominator, and that leaves me with cosine. So now left side equals right side, they both equal cosine, and I have proven this identity to be true. All right, so they will get a little bit harder as we go on here. So I'm going to write left side and right side. You can do this too. You don't have to do a t-chart. So the right side, there's not really much to do. It's just sine x, so we'll just leave that. So this is what I'm talking about when I say compare. When I look at the other side, it just says sine x. When I look at the left side, I have a numerator and a denominator. And I don't want a denominator, so I want to get rid of sine x. So I want to reduce it, but in the numerator I only have cosine, and I need to have a sign, some form of sign, so I can reduce. I know from my trig formula sheet that 1 minus cos squared is equivalent to sine squared. And once I change that, I can reduce. I have two signs in the numerator, one in the denominator, so I can reduce, and that leaves me with sine x. So by looking at the other side, I want to not have this numerator denominator. I want to get rid of that denominator, which means I need to reduce it with something, which means I need some sort of sign in the numerator. So that's why I'm replacing. So you don't want to replace things for no reason. The reason I replaced 1 minus cos squared with sine squared is because I needed to have sine squared in the numerator. Okay. On the left side, we've got 1 over 1 plus sine x. And on the right side, we have 1 over 1 minus sine x. And 2 times secant squared x. So on the right side, secant is the reciprocal of cosine, so I'm going to change that. So secant squared is equal to 1 over cos squared. And what can I do to simplify? Well, I can multiply them together. So that's all I can do. So I'm done on the right side. So now I'm going to go over to the left side. What can I do to simplify here? Well, they're both in sine. So I'm adding fractions, which means I need a common denominator. So in a previous unit, we looked at rational expressions and finding a common denominator. So my common denominator has to include 1 plus sine x and 1 minus sine x, which means that I need to multiply this numerator by 1 minus sine x, and I need to multiply this numerator by 1 plus sine x. So I would have 1 minus sine x plus 1 plus sine x. In the numerator, I'll collect like terms. So 1 plus 1 is 2, and minus sine plus sine is 0. And if I expand the denominator, I get 1 minus sine squared. So then I compare. I look at the other side, and I see, well, they both have a numerator of 2. Perfect. We're good. In the bottom, one says 1 minus sine squared, and on the right side it says cos squared. But I know from my formula sheet that 1 minus sine squared equals cos squared. So I will change that, and then the left side equals the right side. So finding a common denominator is quite common in trig identities, working with fractions. Okay, and this one is similar. We have two fractions on the left. So we have 1 minus sine squared x plus 1 over cos squared x. And on the right side, we have 1 over sine squared cos squared. So on the right side, there's not much to do, but on the left side, we could find a common denominator, which would have to include sine squared and cos squared, which means this side needs to get multiplied by cos squared, and this one would have to get multiplied by sine squared. Again, I compare sides. When I look on the right side, I see that we have the same denominator, so we're good there. The numerator on the left, I have cos squared plus sine squared, and on the right, I have 1. But I do know from my trig formula sheet that cos squared x plus sine squared x is equivalent to 1. And now the left side equals the right side. So it does take practice. You should look at the strategies. Make sure you're only working down the left side and the right side separately. Only use the formula sheet that I have provided for you. I will add some more trig identities. I'll do another lesson and add those to these lessons so you can have some more practice with them.